Good afternoon. My name's Tim Dwyer. I'm Visiting Professor in Building Services Systems at UCL and Technical Editor of a CIBSE journal. And I'm really pleased to welcome you, together with many hundreds of others participating from around the world, in this CIBSE journal webinar, Sibling Harmony, Using Generators with UPS. Working practices that evolved swiftly over the last 3 months have emphasised the need for a reliable and good quality power supply to ensure the reliability of critical systems, including servers, networking and internet connectivity. But of course, commercial and institutional buildings are dependent on environmental services to maintain a safe and healthy internal environment. And these will present power loads well beyond the capacity of a UPS. This webinar by Kohler Uninterruptible Power and supported by Kohler-SDMO will explain how UPS may combine with backup generators to provide a resilient solution whilst dodging potential problems. A story of true sibling harmony. The main presenter, Alex Ems, is Operations Director for Kohler Uninterruptible Power and has 30 years experience of a power protection business and 19 years service at Kohler. Alex started out as a field service engineer, progressing to senior engineer, supervisor, service manager, and now operations director. He has qualified with an HNC in electrical and electronic engineering and a CMI Level 5 diploma in management and leadership. His colleague Peter Wilcock will be on hand to support Alex at the end of the formal presentation. Peter is a mechanical engineer with over 25 years experience designing, building and selling generators and has worked in various roles at Kohler-SDMO for the last 15 years. He will join Alex in the Q&A session to help with any particularly tricky or unusual questions. At any time throughout a presentation, please use the Ask a Question button that's on the screen and you just type in your questions. Alex and Peter will respond to those questions at the end of a presentation as time permits. Any questions that we don't have time for today will be picked up by Kohler by email. A recording of a webinar will be available through the CIBSE Journal website in a few days' time. And so, without further ado, I'll pass over to Alex. Alex, away you go.
Hello everybody, and thanks Tim for that introduction. Thank you everybody for joining us today. This webinar is going to go over a few things around UPSs and generators and how we work them together. So basically on the webinar structure here, we're going to have a quick introduction of Kohler Uninterruptible Power. And then we're going to go on to look at the uses of UPSs. So if we have a UPS, why do we need a generator? Okay, so we look through all that and then we talk about what is a generator and what's it made up of. And also we're going to look at the considerations for installing our generator on the site. We'll have a look at a few of the common issues and questions that we get around fault currents and four-pole changeovers. And this is a little bit of it. We haven't got time in this webinar to go in full detail on some of these things. But we'll also have some sort of takeaways towards the end of questions to ask potential suppliers. And as Tim said, at the end of this session, we should have about 10, 15 minutes or so to answer some of the questions that we receive during the actual webinar itself. So please do put some of those questions in. And as Tim said, if we don't answer them at the end, we will get through back to you on email in the next couple of days. So a quick overview of Kohler Uninterruptible Power. We was formed as a company called UPSL back in '97, and we were the first company to introduce transformerless UPS, especially the modular transformerless UPS, into the UK and Irish market. And this was very successful. And in 2008, Kohler acquired us and we became part of the Kohler Power Group. And as part of that, a couple of years later, we opened our office in Singapore, which is in conjunction with Kohler, where they manufacture generators there. And later on, we acquired Pure Power Systems in Ireland, Now, this is a company we've been working together for a long time, and it was natural for us to acquire them and then to become part of the Kohler Power Group as well. And last year, we rebranded as Kohler Uninterruptible Power to bring all these together, along with the same as of SDMO, Kohler-SDMO, all rebranded. So we're very pleased to be part of the Kohler Power Group, because Kohler are celebrating 100 years in the power industry. So there's lots and lots of experience to be gained from that. So some of our offerings that we do our own UPS and emergency lighting. We do single three-phase UPSs, all transformerless from 1 kVA up to 5 MVA. The emergency lighting is kite marked, and we do modular and standalone and across the whole range of UPS and emergency lighting. And also, obviously, we do the generators, and we have, yes, from small to very large generator installations with Kohler engines and with Kohler-SDMO, hence the joint presentation today. One of the things we are extremely proud of is our service excellence in the industry. We have best-in-class customer NPS ratings. We have lots of contracts, and we offer 24/7 response with our own factory-trained engineers. And you can see some of the statistics down the right-hand side of your screen there. So some of the expertise and the customers we have for this are in various industries, and from data centers to core handling, everything along those lines that need critical emergency backup, we have experience in, and our customer base is extremely wide, therefore with lots of experience in all these different uses of UPSs and generators. So, onwards. So, what are the use of the UPSs? Okay, so UPSs are put in where we have to provide complete seamless protection to any critical equipment. And this is where that critical equipment cannot have any break at all, or any disturbance in the supply. And that UPS is there as a completely uninterrupted power supply to this critical equipment. And this is to ride through these nominations in the mains, and therefore typical run times of a UPS are quite short, from sort of 10 to 15 minutes. And this would typically bridge the gap in the supply, or allow for a controlled shutdown. In situations where it's unmanned, that shutdown can be automatic and be managed by service shutdown software controlled from the UPS. Now, when we want longer run times and shutdown is not acceptable, then we can see the use of more batteries, or very typically we'll have a generator to make sure we can run for as required time that we need. Okay, we can have UPSs with several hours of batteries. Now, that is only typically where it's not practical and feasible to fit a generator. If we have a UPS with several hours of batteries, we have to be very careful in that design to make sure that we put that UPS in, designed correctly to be able to charge and look after that battery for those several hours. So, when we look at why we need a generator, today's activities in business, the generator long run time has become the essential element. It is just not acceptable nowadays not to continue to operate even if the mains disappears. We have to just be online 24/7. So a generator is very essential in making sure that we can supply our customers with the service that we provide to make sure that we run 24/7. Okay, so typically for long run times, we would put a generator in, and this is typically the preferred solution rather than a large battery installation. Although, like I said, it is possible but not always a preferred solution. So with the generator, it's also possible to power less critical equipment as well. So as I said, the UPS will provide typically just the very, very critical equipment that cannot have any break or any change in the supply voltage or frequency. And that's what the UPS does. But we also have essential equipment that's not so critical to the mains. And that is such as air conditioning, lighting, and other office circuits, as you see here. Now, that is where the generator is very good, because on an outage, the generators will be able to supply not only the critical load via the UPS, but also that less critical, but also very important other load like the air conditioning and lighting, etc. So, what is a generator? Okay, so the generator is made up of a number of major components, and we'll just go through these major components here. So we'll look at the engine. Now, this is typically diesel, although they can be petrol or gas. But in the standby industry, we're typically using the diesel engine. Now, these are very similar to the engines we use in vehicles, and Kohler make their own engines a lot of the time. And actually, Kohler are the third largest manufactured generators in the world. And many of these will use the Kohler engines. And these engines are the same as we use in different vehicles. Okay? So, that engine, like in your car, has to be cooled. And most standby set generator sets will have a radiator incorporated into it. To be able to cool itself rather than using other coolants in the building. So that radiator is fitted typically in front of the engine with the fan drawing the air through to that. So that will move the fluids around the engines to keep it cool. We also have to control the engine. We have to be able to start it and stop it, control the speed, and also to monitor the engine to make sure it's running correctly and safely. Like all modern engines now, there's a lot of sensors around the engine, and we have to be able to manage that continuously. And that control panel is part of actually just managing the running of the engine. Okay. So all engines, generators need fuel. So we do have a fuel tank, and on sets sort of below about 1 MVA, most of the time we'll have a self-contained fuel tank. Now these typically sit underneath the engine. We will talk more about fuel tanks later on during this presentation. However, a lot of the time they're situated within the enclosure of the generator underneath this. Okay. So once we've got all the engine running and it's actually able to output power, that power we need to convert into electricity. And for this, we use the alternator on the end of the engine. Now, the alternator is the part that produces power, and it could be single phase or three phase. And this will put power out. And then we have to control where that power goes, and we'll talk about that changeover facility later on. Okay. So generators do come in all variety of sizes and packages. They can be installed inside buildings. However, very often they will be installed inside a self-contained container here, as you can see bottom right. Okay, so that is a typical thing. We move that along, put it outside the building, and that will be self-contained, and we cable that in and out from that point. Okay, so, but we also have some installations, okay, containerized, but they're so large that they actually have to be put together on site. And we can see that on the top right, where that comes in modules, and it's built actually up on site as well. So some generators are containerized, and these are typically for temporary solutions and hire solutions where we can bring this along, put it on site and cable it into the building to be used as a temporary solution. Okay. So some of the considerations we have to make, and we go through these, the sizing of the generator, the AMF panel, and we have other things to consider like the noise, the cooling, exhaust, vibration and things like that, and we'll have a quick look at those things. Then we have installation and positioning, and of course the fuel storage for the generator as well. And we mustn't forget that maintenance is critical for generators as is for anything else, and we will have a look through that as well. So sizing. We have to make sure that we understand what we're going to size. Okay. Generators are used to feed the UPS and also for some other non-critical stuff. So when we are actually feeding the UPS, and other sensitive equipment, we have to make sure the alternator is fit for use with the type of load that we're doing. Now, typically sensitive loads, we may have to upgrade that alternator, but also we have to make sure that the engine runs at a constant frequency, and this is typically controlled by an electronic engine governor as opposed to a mechanical. So we also have to consider loads which, like cooling loads, that potentially have very high starting currents. Now, like many things, there'll be a limitation to the inrush that we can have on the generator, as you would on any supply. So we have to be very careful of what that is on when we're putting onto the generator. So that impact load, this can be it's the capability of the engine to maintain the output voltage and frequency depending on the load that is applied in one step. Okay, so on big sets that can be less, and we also see that on modern sets it's also is actually declining. So we have to make sure we put the load onto the generator as stepped as well as we can, and this is where we work very well between our modular UPS and generators, because we can step in the load very managed and very small and keep that generator running at the right frequency and voltage. Okay, so like I said, modern engines are having a decreasing load acceptance, and this is where we've been having to make sure the engines are as efficient as possible. There's been a lot of change in turbocharging engines, and that has actually decreased the impact load that a modern engine can actually take on. So it's very critical that we size this very, very carefully. So next part of this is the AMF panel. Now, the AMF panel is the automatic mains failure panel. So these are the size dependent on the installation and the size of the generator, and can be from tens of amps to thousands of amps, either wall mounted or floor mounted, but also can actually be built into the switch gear, or it may also be on the end of the generator, actually in the generator enclosure itself. So the AMF panel, it is the part that tells the generator to start and stop. So what it's doing is sensing for the voltage from the mains and also from the generator. And when it sees the mains goes out of tolerance, which would be programmable, it typically will wait a few seconds, because we don't want the generator to start immediately. There's a dip in the mains. We make sure that the mains is out of tolerance for a set period of time, and then we send a signal to the generator to start and come available. And once it's available, the actual mains failure panel would do this changeover from the bad mains onto the good generator. And during this time, it will always be sensing, looking for the mains to return. And when the mains returns, again, it might not be stable. So there'll be a timer, and it's again programmable, that we will set and typically last for a couple of minutes to make sure that mains is healthy. And then once we're happy with the mains, we will transfer back from the generator onto the now healthy mains, continue to supply the critical load. Now, again, also as well, once the generator has come off load, it does need to cool down, and this panel will do the cooling times to allow the generator to run for a required time to cool down before we actually turn it off. During that time, as also, if the mains does fail, the generator is also still available to be transferred immediately back on. So inside the AMF panel, you can see this drawing here and a schematic of the generator and main supply coming in. So the AMF panel has voltage frequency sensing on the generator and the main supply. And then we can see here, the way it's cabled up, that the main supply also feeds sort of non-essential equipment that will not be fed from generator. Okay, so on generator, when the generator is on load, it'll be feeding the UPS, air conditioning, emergency light and alarm systems. But in this case, it won't be feeding the general lighting and general heating. So that is dependent on what's critical in your installation, and also determines the size of the generator as well, depending what the customer decides is essential load. What you can also see here as well is on this drawing we put a bypass switch for the AMF panel. Now, it's not necessarily absolute necessity, but it's always a good idea to have a bypass switch in your installation, and this allows for the panel to be tested, repaired, replaced, whatever you need to do. But it's like having a manual bypass on a UPS. It is a very, very nice to have option that we would recommend that you put into any installation. Okay, so hopefully that tells you what the basics of an AMF panel do. Again, they all come in different sizes and shapes and varieties. But we'll move on. Noise attenuation. Engines are noisy. Actual movement of air is also noisy. And we have to move a lot of air to keep this generator cool. Okay, we've seen the big radiators on there. So depending on the environment, where the actual generator is located, the regulations around where there is, we have to make sure that the engine is running to those requirements. And that might mean putting some large noise attenuation on. Now, these can actually take up a significant space, but they do reduce the noise, and sometimes it's essential. But these will add, obviously, cost and space requirements onto that generator itself. So the actual engine noise from the combustion is silenced, like in your vehicle, with silencers. Now, this depends where you will put this engine, if it's in an enclosure or if it's in a building, but we have to make sure we put silencers on to this. And you can see in this picture that this is an installation which got built-in silencers. And if it's in a building, these exhaust pipes may have to go a long way through the building, and that is a very, very critical design to make sure that we're not putting too much back pressure onto the engine, and that has to be very, very carefully designed. And it is almost critical that you talk to the supplier to make sure that that is done correctly with that. So on this picture we can see the exhaust, we can see the air intakes and outtakes, and we can see that these silencers are built in this part of the structure inside this building, and that has to be all considered when we install these generators in the building. So, well, one point here is just on the radiator. Obviously, we need to duct the air, and we typically have some plenum chambers around the radiator and the outlets of the building, or the container to make sure all the air is flowing in the right location and direction to make sure we keep this completely cool. So another thing I mentioned is vibration. Engines vibrate a lot, as we know, especially when they're put into buildings. We can have significant problems with vibration throughout. So we have to make sure that we put anti-vibration mounts onto the generator itself. And these are mounted beneath the engine and the alternator. And these are rubber mounts. It's very similar to what we have in vehicles that allow the vibration not to be transmitted through to the container or through to the building. Although obviously we're going to get a little bit, but we reduce that as much as possible. You know, one of the things also to note is the generator has his exhaust pipe bolted on, and if that wasn't isolated as well from the vibration, again, we'd have significant noise coming through from vibration through to the actual exhaust silencer as well. So we have to make sure the exhaust system has good quality flexible steel joint between the exhaust and the actual engine itself. So coming back onto fuel storage. Now, fuel to the generator is like a battery to the UPS. However, a battery is very difficult to refill on the go. But with a generator, we have the options that it can be refilled while it's running. And this is very important to consider. So we can decide how much runtime we need for the generator. Now that can be from hours to days to weeks, and then we can decide how much fuel we actually need to have on site, because if we can refuel it and get fuel in the required time, we can limit the amount of fuel that we have to actually store on site. Obviously that's very critical that we have a contract in place that we can get the fuel in the required time, but it's an option that needs to be considered when we're looking at the actual fuel storage that we need. Okay, so like I said from the beginning, typical fuel tanks are bolted into the bottom. Now, less than 1 MVA, we typically have, depending on the set and the tank, sort of 5 to 12 hour run times. We can have extended base tanks that can run for longer, maybe a day or two. When we want bigger than that, we have to have separate fuel tanks, and typically on large generators, we would have to have a separate day tank or bulk tank as well for that to run anyway. So when we have a separate fuel tank, some examples here, we have to make sure we get this plumbed in correctly. Obviously there's going to be pipe work, there's going to be pumps, and that decides where the generator is going to be sited and where the fuel is going to be sited, of how we're going to get the fuel from first of all from the fuel tank to the engine, but also we have to consider refueling the tank. So there's going to have to be pipe work for that possibly, especially if it's inside a building. Okay. One of the things about fuel storage is this is standby sets. This big tank of fuel might not be used for a long time, except for testing. So we have to make sure the fuel's in a good condition. So it can be advisory to have a fuel polishing system that we can actually clean the fuel on a regular basis to make sure that we can get rid of all the contaminants, which are typically water and sediment from the fuel. If the fuel's no good, the engine won't start, and obviously that's very, very critical for a standby set. So, okay, so what we're going to have to look at, and one of the slides didn't work properly there for me, but there's obviously a lot of regulations around fuel storage as well. And we have to make sure that we make sure we comply to all the regulations, things like bunding of the tanks, pipe work must be double skinned as well, and all those things that we can, very important to understand from your supplier as well. So moving on to the maintenance. Now these are obviously very critical as well. Standby sets are sit there and relied upon to start, when you need it. So we have to make sure that it is regularly started and regularly load tested, and ideally monthly. Actually starting the generator on its own will not guarantee it will come online. One of the big problems we see is people start generators but don't actually bring it online. So they don't test the AMF panel, they don't test the changeover. This also needs to be tested periodically to make sure that when you need it, it will happen. Okay, so it's a critical thing to do. The engine must be regularly serviced, as we would with our vehicles, and there are consumables required. Filter changes, oil changes, pipe changes. We can test the oil if it needs it, but that frequency depends on the usage of the standby set as well. So that actually can vary, but it is a very, very important thing that these are regularly serviced, tested, to make sure they come online. Now, one good way of doing this is to have remote monitoring. Remote monitors come in all sorts of types and varieties and complexities, from simple to complicated. But what's important to note is that the remote monitoring system is able to integrate the engine. If the engine has an issue, it will remote out. Very often, generators are in car parks or roof plants or plant rooms, and they're not regularly looked at and checked. And our remote monitoring is a good way of doing that. It can be used to do an automatic test on a weekly or monthly basis. And if there's any issues with that, it will alert someone. And that's the important thing, that someone is alerted. And that will allow any problems to be highlighted before you actually have an outage and you need this standby set to work. So, once we've decided we're going to put an installation of a generator in, we have to make sure that we do it properly. So with the electrical considerations. Now, that might depend if it's going to go in as a modification to the infrastructure, or it's going to be designed in from the beginning. And that, both things have to be considered. And some of the things that we get asked around are fault clearance and neutral referencing when we're looking at generators as well. So when we're putting a generator in, we have to make sure we understand the downstream fault clearance. So we have to consider the fault capabilities, or fault clearing capabilities rather, of the generator, because these could be very different to the mains. And this is very important to consider, especially on installing a generator to an existing system. Okay? So even if you've got a UPS and that's the load or part of the load, the downstream fault currents could still be transferred to the supply or to the generator itself. So look at this little quick diagram here. We have the mains running as normal, and we have a protected device protecting the load for any downstream faults. And we can understand that the potential fault current from the mains is typically and generally much higher than it is from a generator. So we can't solely use the actual potential fault current from the transformer to select the protective device, because when it's running on generator, we then have a different potential fault current, and this might possibly have to be the parameters that we use to select that protective device. So also when we're looking at putting a generator in, will all the protected devices still operate correctly with the design and capabilities of the generators that you're putting in? Okay, so it's an important consideration to look at. Now, another thing that we get asked about is neutral earthing, especially when we have UPSs in. So we have to consider it. In the UK, we typically have to use 4-pole changeovers. And what that means is that during the changeover between mains and generator and vice versa, we will have a time when the neutral earth is not connected and it's not referenced together. So if we look at this little diagram here, we can see this 4-pole changeover. And typically when we're on mains, you can see here that the output is referenced, the output neutral is referenced to the earth at the start point of the transformer. Okay, so during the changeover period, there is no connection to any start point during when both circuit breakers are open. So when we go back onto the generator, now the output neutral is referenced to earth. Okay, so what's the problem here? Now, if we don't have a UPS downstream, when we have a changeover, we lose the neutral earth reference, but there's no UPS, there's no output voltage during that period, so it's not a problem. However, if we do have a UPS in circuit, the UPS continues to operate when the mains has failed or when both breakers are open on the changeover. And the output of the UPS is still outputting 240 volts line to neutral, but that neutral now is floating and is no longer referenced to the earth, as we've seen in the previous diagram. So that does become a problem because there's no earth fault path in the event of a short circuit on the output of the UPS. So we can see this now in these diagrams. So in normal operation, output of the transformer, UPS, is the output neutral is referenced to the TX of the supply. So during that changeover, the UPS now is operating, it's outputting voltage, but that neutral is not referenced to any input earth. Okay, now in any UPS there is no neutral earth bond. Even if it's a old transformer-based UPS or transformerless, there is no neutral earth bond within the UPS. If we want a neutral earth bond at the UPS or after the UPS, we have to do something about that, irrelevant of what kind of UPS it is. And that's very important to consider. Once we're onto generator, that neutral is now bonded to the start point and to the earth at the generator. So the output of the UPS neutral is now referenced to that generator earth. And obviously, we're back into a safe condition. Now, this is a big subject. We have different CPDs on that. There's different things we can do. We can limit the changeover. We can use an isolation transformer, galvanic isolation transformer, to recreate a neutral earth point. We can use overlapping neutral systems or neutral earth contactors. Like I say, it's quite a subject. We get a lot of questions about this, but what we're putting over here is an important consideration for you to look at. So, once you've decided you want a generator, we're going to have some information to hand when you go to a supplier. We want to know what loads you have. Very important, we need to understand what load it is, what type of load it is, UPS, general power. Is there any of the loads are safety services or regenerative load? Because that will make a difference in how we select things. And of course, we need to understand if it's just like the critical load and non-essential load, what do we want to do? And are we planning on changing that load requirements in the future? Once we know that, we want to know how long we need to keep this set running for. can we put refueling in, or do we need to put the tanks in required for the runtime that customer requires? And also, does the customer want redundancy here? Like UPSs, we can add redundancy in by paralleling generators to have N+1 capability in case of a failure of a set, that we still have another one available. So once we know all that, we'll understand the space requirements, and we need to understand what's available. So is it going to go inside a building, outside in the enclosure, or is it going to go on a roof, for example? So then we will work out where the fuel goes, inside or outside, located depending on the runtime, actually in a container with a set, or is it in a remote fuel location? And again, we have to consider at this time, we have to consider how we're going to get that set in, if it's going to, especially if it's inside, or if there's any difficult location, and how we're going to monitor it and maintain it. It's also very, very important. Some of the installations outside, if we're going to put it like between buildings, you get a lot of resonant noise, and there might be residents around. So we have to understand all of that type of thing. So, what we're going to do is talk to the suppliers, make sure we understand the performance of the generator, what kind of warranties it's, what the overload, short circuit, the actual step loading, things like this. And then we can determine the footprints depending on, the fuel and actual silencers and things like that, and how heavy this is going to be, with the fuel as well, and make sure that you can comply to the regulations around all the noise and emissions in some places that are also very critical as well. So, the supplier, do you have the capability to manage it and monitor this situation? Do they have fuel polishing contracts and refueling available? And also things like, is the solution in stock? What's lead times? What's also, the supplier's capability when it comes to service as well. We have to make sure that this set, it's a standby, it's critical. We want this to operate. So therefore, after service is also very important with number of engineers, factory trained engineers, coverage, direct and factory trained. And where the spares, we have a lot of situations where you need a spare. People say there's a spare available. Where is it, and how available is that to get? So I really do hope that's to help to give an introduction of where we put UPSs and generators together, and some of the questions that we get asked, and some of the considerations that we have to make. And we can see that it can be very complex, and it's something that is very worthwhile to speak to suppliers about. You've got the experience of both, to make sure that everything works in harmony with your installation. So that brings me to the end of this. So we're going to go, I think I've seen some questions, a lot of questions, I believe, popping in. So myself, yeah, good. So myself and Peter will field some questions from you, Tim, if you've been checking all these out, and hopefully we can answer as many as we can in the last 15 minutes we have, and let's see what we got.
Okay, thanks, Alex. Really interesting. Lots of information, applications to think about. We'll now take questions that have been entered into the question box throughout the presentation. They'll be answered by main speaker Alex Ems and his colleague Peter Wilcox. So let's go for the first one. This one's from Alice, and she asks, how quickly will the generator respond to a mains failure?
Okay, well, I can take that straight away. That all depends on how quick we want it to respond. Like I was saying in the presentation, we typically actually delay the startup of a generator to make sure that the outage is real. Generators can respond and start up very quickly in seconds, depending on the size, but can be available within seconds to be available. But typically, we will slow that down and make sure the outage is real before we actually bring the generator on, because we don't want it starting and stopping unnecessarily. So I hope that helps.
Okay, thanks for that. This one's from Daniel. Daniel asks, what as a percentage would you, as a manufacturer, accept as a maximum step load? I think you spoke about that on around slide 12.
Yeah. Peter, can you take over? Yeah. You've got a lot more experience on that.
Yeah, I can. Engines vary in load acceptance, depending on the size of the generator and the type of the engine used. Anything from 50 to 75% load impact is normal, but it's not one figure for everything. They do vary depending on the kVA of the generator and the make of the engine. So, but 50 to 75% is the sort of ballpark where they generally are.
Okay, that's clear. Thank you for that, Peter. And now a question from Vicky. How long will a generator run for?
Okay.
Fuel tank.
Yeah. How long's a piece of string? We can set that to run for whatever time we want. I mean, some generators are primary power and run continuously.
Yeah, 24/7.
Yeah, 24/7. Pete, if you want to carry on, I mean,
I mean, it's all about how big the fuel tank is. The generators these days are designed to run 24 hours a day, 7 days a week. Whatever kVA is, that's what it is. It should be able to run. It's all about fuel supply. So,
okay, so
obviously maintenance needs to be taken into consideration, and maybe buy 2 generators and run one each week continuously, and we sell 2. So, you know.
Okay. So very much depends on the application, I think. Yeah.
Yeah, it does.
Our next question. This question's from Hammond, and Hammond asks, what's the advantage of using a standby generator as well as a UPS? Would this have effect on maintenance costs? Something you just spoke about, of course.
Yeah, absolutely. I mean, the generators in UPSs are different. A UPS is there to make sure that absolutely critical load, which cannot accept any fluctuations, continues to operate and to run. So, it's depending on your runtime that you want. So if you want only want a 10-15 minutes backup, then no, you don't need a generator. But if you want extended run times of several hours, where we know that mains failures are typically under a minute or over 3 or 4 hours. So if you want to run to that, typically you want a generator as well. And in those cases, yes, we have to maintain both. But how critical is that load to your operation and to your business, and how much do you lose if you cannot run for those hours? And that's important to understand.
Okay, thanks for that, Alex. A question here from Tom: Can a generator or UPS provide a backup supply to 2 separate buildings, so from 2 separate substations?
Not quite fully understanding the question, to be honest. I presume, can a generator be used to supply 2 buildings if it had separate supplies? Yes, it could.
Changeover panels.
Yeah, with the changeover panels, correct, Pete? So yes, we could do that. Typically, you wouldn't do it with a UPS, although it's physically possible, but typically you wouldn't. But with generators, yes, you could have a large generator plant that feeds different buildings with separate substations. I mean, we also see that inside a lot of buildings themselves that have more than one intake. So the generating plant will supply the whole building or part of the building, depending on if one or more of the supplies fail.
Okay, thanks for that. A question from Stephen here. With the environment in mind, what options are there for generators which do not use fossil fuel? And he tags on there that similar with the UPS. What new technologies are there?
Pete, you were talking about environmental the other day.
Yeah. I mean, using fossil fuels, we do have cleaner burning engines, being tier 3 and stage 5, but non-fossil fuel, as in gas, LPG. We do have an arm called Clark Energy that uses gas generators, but they're generally much larger generators. At the moment, there's no hybrid system coming along that SDMO are doing, other than wind, solar, conventional systems. It's not available at the moment. We're still using fossil fuels because it's 100% reliable. 7 seconds and your generator is online using fossil fuels.
But we've also got much newer options for the generators themselves are much cleaner, even the modern engines, and also with the scrubbing exhaust and things like that. So.
Yeah.
Okay, that leads us very nicely into a question from Robert here. Perhaps you could just explain, and I think someone's been doing their homework here, what is an SCR, after treatment system?
Yeah, it's an exhaust after treatment system that uses an urea injection that is used on newer equipment and on older equipment. If you've already got a generator installed somewhere that you don't want to remove, but you want to improve its emission level, there is a system available through UPSL, an SCR system that can be retrofitted to older generators to clean the gases coming out of the NOx levels by reducing them and bringing it within tolerance of latest legislation, or as close to. So the SCR system is an after-treatment cleaning system that is available.
Okay, and I think that stands for Selective Catalyst Reduction as well, for those who are not familiar with that acronym. Next question here from Nicholas, and Nicholas asks, do the fuel tanks fitted to the units, the skid of the units, require to be bundled? Bunded. And if so, are they? Perhaps you'd explain what bunded means first as well.
Yeah, it's a double-skinned fuel tank that if it decides to burst itself, it catches the burst into another lining. And then the legislation is anything above 200 litres, because an oil drum is 205 litres. Anything above 200 litres needs to be bunded, and yes, they are all bunded. Everything that UPSL install are bunded, and so are the fuel lines very often from remote tanks. Yes, everything is bunded.
Okay, thanks for that. If sticking to a tank, this is from Dan, if it's located within a building, what are the ventilation requirements?
Fuel tank needs to breathe, fuel expands. You need to consider fire hazards when you're putting a breather in a fuel tank, and where you're putting it. There's nowhere where there's any form of naked flame or combustion can be caused, but breathing of fuel tanks needs to be done safely in compliance, depending on where the installation is. If it's in a basement, but all fuel tanks need to breathe.
Okay, thank you for that. Very clear. A question from John here. Would you always go for a modular UPS with a gen set, or do you also use a DRUPS unit depending on application? That's DRUPS.
Yeah, DRUPS, diesel rotary UPS. That has its generator already connected, and it's all in one. We're seeing a big move away from DRUPS to static UPS. And we're also seeing, when we look in the static UPS, a big move towards modular. Modulars have, lots and lots of advantages that we've now come as normal. But as far as using modular onto generators, it does help that we can step in the load very, very well when we put a modular UPS onto a generator, although we do have a lot of standalone UPSs running on generators as well, with absolutely no problem. But we just have to understand the installation, what the step loads are, and therefore we can size everything accordingly.
Okay, thanks. And DRUPS, of course, stands for Diesel Rotary Uninterruptible Power Supply. People can look that up later on. Okay, our next question. Is it a good idea to keep the generator running until the UPS battery is substantially recharged in case the mains fails again? That's from Peter.
Not necessarily. It depends on the autonomy of the UPS battery. You know, if we have a good 10-15 minute autonomy on the UPS, and we're starting the generator within 30 seconds, you know, we've still got, you know, 9 to 14 minutes left of battery. So we can do many short mains failures. So there is no need to keep the generator running until it's fully charged. However, if the generator started in the correct time, the battery shouldn't have discharged too much anyway, so wouldn't actually take long to recharge. You know, we are seeing a shift towards some smaller batteries when it's installed with a generator. But those short batteries won't take a long time to recharge anyway. But you don't have to wait for it to do 100% recharge. I mean, typically batteries recharge very quickly at the beginning, but to actually get to 100% typically takes 24 hours. So we certainly wouldn't be doing that. So a typical installation, no, not to worry about. The battery should be able to take several hits, and generator starts without a problem.
Okay, thank you very much. Got a question from Zia here, and Zia asks, what can be the negative consequences of using a automatic mains failure panel, an AMF, or is it absolutely necessary? Okay.
An AMF panel, is an automatic mains fail panel. Strictly speaking, not absolutely necessary, but it means if the mains fails, someone has to go and start this generator and do a manual changeover. So, you know, nowadays that's typically not acceptable. So I wouldn't want to say it's absolutely necessary, but it's highly recommended.
Yeah.
Okay, thank you very much. Interesting question here from Ian. Ian asks, what design considerations are there for using a UPS to back up lifts or elevators?
Oh, okay. Depends on the lifts and the elevators. It depends how they run. But typically, you're going to have inrush current and locked rotors, fault loads to consider. Lifts, elevators are typically life safety situations, not always, but typically. So therefore, the fault clearance capabilities of UPS has to be able to clear the downstream faults in the event of emergency, as in, i.e. on battery. So that's a big consideration. Another big consideration with any motor load is it regenerative? If we're going to have regenerative load, we're going to be backfeeding the UPS, and the UPS has to be specifically designed for those installations. But it's something that we do quite a lot of for life safety, is to use the UPS in those situations. But like I said, we have to fully understand the requirements of the load and the customer to make sure we can give the correct solution.
Okay, I've got time for just one more question, I think, before we're out of time today. We have a question from Brian here, and he asks, is fuel polishing essential, particularly when there is a monthly run? Perhaps you just briefly tell the audience what fuel polishing means as well.
Peter, do you want to take the last one?
It's a system designed for cleaning the fuel, because predominantly what happens, you put 24, 48-hour fuel tanks into the basement of a building, then you run a generator for 1 hour every so often on load, and what happens is the fuel can start to break down. So you can then clean the fuel and pull any impurities out from the fuel by using the fuel polishing system. Because leaving fuel stand for 12 months, 18 months at a time, even though you're only running 1 hour, which is taking a small amount of fuel at the tank, isn't good for the fuel. So a fuel polishing system cleans stagnant fuel, which is a problem you cause yourself by putting the installation in, but it's needed. It's essential these days for a larger installation. Fuel polishing system definitely to be used.
Thank you. It's an essential for this sort of application.
Yes,
great. Thank you very
definitely.
much. Well, we've come to the end of our time. We've got lots of questions outstanding, and I know the team at Kohler will pick those up and come back to the questions by email. But just to say, there will be a recording of a webinar with a full audio and the slides on the CIBSE Journal website in a couple of days' time, so you can go back and review this, because you really need a further opportunity, I think, to review the massive content from today's webinar. So thank you for attending today, and thanks to Alex and Peter for a really informative and timely presentation. Really good, very a great webinar, and something that gives us plenty to think about. So thank you, everybody. And this is Tim Dwyer in London. I look forward to joining you with you again at the next CIBSE Journal webinar, and I wish you a good day. Good afternoon.
Thanks, everybody. Thanks for listening in.
Thanks a lot. Bye-bye.